We have known beyond any doubt for decades that both time dilation and length contraction actually occur. In the 1970s, 4 atomic clocks were synchronized and flown around the globe twice, and when compared to a reference clock on the ground, all the moving clocks differed from the reference clock by exactly the amount predicted by relativity. This is a very outstanding realization, and here's an example of why. Here's a graph of a car travelling constantly north from Kidsgrove to Manchester at 10 miles per hour. It is making no progress in the east direction as all of its speed has been used to go north. Now here's another graph of a car travelling constantly east from Crewe to Kidsgrove, again at 10 miles per hour. It is making no progress in the northward direction as all of its speed is being used to go east. Now let's start at Crewe and head out to the northeast. Even though the car is still doing 10 miles per hour, it is doing less than 10 miles per hour in the east direction, as some of its speed is being used to go north also. Space and time can be thought of in the same way. Everything in the universe is moving through space and time at the speed of light, the maximum speed available. Imagine time replacing east and space replacing north in our example. If you were sitting still in space, not going north, then you would be travelling at the maximum speed through time. But if you start moving in space, your progress in time will slow down, since some of your speed is being diverted. The faster you go in space, the slower your progress in time, and if you could travel at the speed of light through space, then you would make no progress at all in the time direction, and time would stand still, just like it does for a photon of light. If you could go faster than the speed of light, you could go backwards in time. Remember, if different observers have to agree on the speed of light, then they must disagree on the components of speed, time and distance. Time and distance both shorten for moving observers. These unusual effects of relativity, time dilation and length contraction, depend greatly on your velocity. At everyday speeds they are simply not noticeable, as the fastest humans have ever travelled is a few miles per second, just a tiny fraction of the speed of light. But in the universe, space and time are no longer absolute, and are only relative. Einstein called this space-time.